I know everybody has a great plan for the new year, 2011, to get the most out of every day, not the least. So that's what we're going to start right now. You're going to notice that the angles that we're talking about are what we talked about at the beginning of the school year. This is chapter 5. This starts the trig components of this course. The other part is pre-calculus. There was trigonometry and pre-calc together. Trigonometry by itself at Parkland is called Math 125. Pre-calculus by itself at Parkland is called 124. The two courses together are worth 5 hours of credit called 126. So they have to have both components in this book. Now, it used to be two separate books. 2 years ago, they went to one book that had both courses in it. Very much like calculus. If you've ever seen a calculus book, that book is actually 3 courses for one textbook. So you take calculus 1, 2, and 3 out of one textbook. This textbook, there's actually 2 courses. So this chapter 5 starts the trig component of it. Oh, interesting. This is crash, so I'll have to go old school. All right, that's okay. Anyway, chapter 5 starts the trig. At the beginning of the year, we had chapter A that was trig. Talked about the unit circle, talked about coterminal angles, things like that. That's fantastic. You'll see some of this information repeated. What else you must have is a 9 by 5 or whatever size note card that fits inside your calculator without being folded. You do not have to have one of these, but you can have one of these. You cannot use it for tests, but you can use it to help you remind you of things that are needed, not in this class, but in the next one for those that are taking it. Because once you leave this class, you won't have all this information on one nice reference card. Okay? That's what you're going to be making this chapter, and the next chapter is a reference card involving trig to use when you're solving calculus problems. It's a quick reference that you can use, that you put a lot of things on. Because yes, it does happen. Some people forget things over time. But it has to be in your calculator. It shouldn't be folded up. Something you just take out as a quick reference. Okay? A lot of my former students come back and say they hadn't had math in a while. They went back. They took math, found their note card. Life was pretty good. Okay? We're going to start pretty easy today with angles. That's why we're starting so early. I figure everybody showed up today. Might as well get after it and get started. Yeah, but the people that are not important, but the people that are here are people who like to get after it. They like to get the most out of every day.
So your point is she's not.
The point is that she will be here tomorrow, hopefully. That's fine. We can do this. The x-axis is going to be the initial side. The terminal side will be any place an angle stops. We've drawn angles like this before. Again, I'm going to go through this as if we didn't have chapter A. All right? But coterminal angles means angles that end in the same place. For instance, this angle goes all the way around. Do you remember how many degrees there are in a half circle? 180. So this angle, say, goes 180, goes 360, and goes 30 degrees more. Let's say this angle is 390 degrees. I'll use theta. That's 390 degrees. Another angle that could be coterminal, that would be just a 30-degree angle. Coterminal means they end in the same place. For us, usually it's the same quadrant. Remember the quadrants, 1, 2, 3, 4? You are taking the ACT, so we'll run over a few things like that. But usually we talk about coterminal angles when we're talking about the coordinate axis. Okay? Positive and negative, things like that. But excuse me. Coterminal means they end in the same place. All right? This one, theta, is a negative angle. It's going counterclockwise. Okay, you can see it's spinning around, 180, negative 360, negative 540, negative 630, so around negative 690. If theta were negative 690, it'd be coterminal with the 390 and the 30. they would end in the same place. Okay? So that would be theta. Drawing them out isn't really too difficult. Normally you don't go past 1 revolution, but you can if you like. So initial side is where you start, 0 degrees. The terminal side is where you end, negative 690. And we're talking about degrees. Okay? You remember which civilization came up with the degrees?
Nope.
It was actually the ancient Babylonians. Their counting system was base 360. Our counting system today is base 10. They did everything in base 360. They had a lot more options with fractions than you do with base 10, so they liked it a lot better. Anyway, yeah, so they came up with actually why there are 60 seconds in a minute and 60 minutes in an hour. Actually, it's base 60, not 360. Did I say 360? It was base 60. Well, you know how base counting systems work, right? You know, like 11, and base 10 means 11, but base 2 means 3.
Yeah.
You know the different counting. You don't know the different counting systems. Oh my gosh! How'd you get? All right, we count in base 10, right? So this number represents 1. So this number represents 100, 2 tens, and 1 1. So we say as 120 for 2 tens, 1, right? Well, the ancient Babylonians had base 60. Oops, sorry, I need an eraser. Smartboard's not working real well. That's a little too big. That's all right. Anyway, they had base 60. So this represents 1 3600. This represents 2 60s, which would be 120, right? So you're at 3720. And it represents 1 1. So to them, this number would be 3,701, something like that. I lost track, but you get the idea, right? The base determines how these digits correspond to what number you're referring to. Base, let's go with base 2. Base 3. We'll go base 3. 3 to the third, 3. Anyway, so this represents 1 1. Any number that 0 powers the 1's column. Got it? This represents 1 3. So this is actually the number 2 3's makes 6 plus 1 is 7. So far we're at 7. And then you got 1 9. So that number represents 16 in base 3. Base is the base of your columns, right? Okay. Anyway, I'm surprised you guys have gotten this far without that knowledge, but I'm about to rewrite the algebra curriculum. Anyway, they had base 60.
I think it's fine the way it is.
Why is that so important? Well, because they ran what's called cuneiforms in it. Anyway, this was the 0 columns, right? And this was the 1's column, right? And this was the 2's. So they called this the first column. They called this the second column. 60 seconds in a minute because it's in the seconds column. Get it? That's why it's called seconds, because it's in the second. Okay. Got the idea? Why aren't there 60 hours in a day? Well, because they could tell time, and the hours only went to 24. Okay. So anyway, 60 minutes in an hour, 60 seconds in a minute. All right, we get the idea. All right, anyway, that's how the base works. Luckily for your calculator, you only have 2 bases for logs, natural logs, E and 10. So anyway, we've already talked about this, the positive angle, theta greater than 0. The negative angle, positive angle. Oh, they're using different letters. Sorry, I was using theta. Alpha. Alpha. I forget what that one's called. I just call it Y. Anyway, those are all Greek letters. And you can draw this, 60 degrees into the first quadrant. You should be able to tell they're getting ready to draw the unit circle. Anyway, one lap around is 360 degrees. And then you go 60 degrees more and you get 420. these two angles are coterminal. Okay, they end in the same place. They're coterminal. 780, 2 laps around. 720 and another 60 makes 780. Again, this angle ends in the same place as the 60-degree angle. Okay, and then you can go the negative route also. Negative means you start at 0 and you go down. Does anybody remember what this is called when you put an angle this way starting at 0? There's a special name for it. Oops. When you draw an angle in standard position, 0 is the positive x-axis, 90 degrees is the positive y, 180 is the negative x, 270 is the negative y, 360 is one complete lap around. That's known as standard position on the xy coordinate plane. All right. I love trig. Trig is way better than pre-calculus. Way better. Radians. This is where it gets a little fuzzy for people. There was a teacher here one time, taught, and he said, when I was an undergrad, I never got used to what a radian was. And I ignored it, thinking it would go away, and it never did. And then I had to fail the class, I had to retake it. So I had to learn what radians is. Anyway, 1 radian is the measure of the central angle of a circle. What the heck does this mean? Subtended? Anybody got any like English ACT skills they can throw out here? Huh? Sub is below. Tended? I usually say cut out, where it cuts out. Because the unique thing is equal length of the radius. If this is r, the radius of the circle, this length is r. Okay? And if so, then that means that would be 1 radian. Theta would be 1 radian. That's really not a whole lot of importance until you try to find out how the radians and the degrees interact with one another. Central angle means it's in the center, right? Central, center. So that's at the center of the circle. Do you remember what type of angle this is when it's all the way out here? Inscribed. It's equal to half of this. So here, theta would equal 1/2 of a radian if it was on the circle. Inscribed angles are half of the arc. They subtend. Remember, I call them intersect. But anyway, that's the strict definition of a radian. Radians are ways of angling measures that allow you to go from the pre-calc to the trig world seamlessly. Radians are a way of measuring angles in terms of real numbers. Degrees have a problem, don't they? How do you write 60 degrees? Yeah, 60 degrees. Well, how do you write an angle pi? That's an angle measured in radians. Pi. Well, you write it as pi, right? That has no unit with it. That is a real number. The degrees has a problem. You can't solve algebraic equations in terms of degrees. You charge them in terms of real numbers. Solve them. So you can solve trig equations with real numbers using radians, whereas you couldn't solve them with degrees. You couldn't be able to go back and forth between the two. Until radians came along, there are two separate disciplines. With radians, you can merge them together into one nice field, and you can solve things. It's great. Why is that important? Well, because your calculator has 2 modes. One's degree and one's radian. How do you know which is which? Easy. Do you see a degree symbol? You're in degrees. You see a degree symbol? You're in radians. It tells you. It tells you which is which. And you have to change your calculator accordingly if you're going to use it. Okay? So anyway, 180 degrees is equal to pi radians. That's if the radius of the circle equals 1. 180 degrees equals pi. Do you remember why 180 degrees equals pi radians if the radius is equal to 1? Come on now, you're the best and the brightest we got, except for 6th hour. Yep. The diameter would be 2. I agree. You're almost there. The radius would be 1, correct. Now the radian isn't measured at the central angle, is it? The degrees are measured at the central angle. The radian is this length, okay? Degrees are measured at the central angle. Radians are measured on the circle. How's that? Does that help distinguish between the two? So if I go stop. That's 1. 2. Oh, nice. 3. 3 and a little bit more makes 3.14. Normally you call that what? Part of the circle. A semicircle, it's called a semicircle. What if I go all the way around? Circumference. And what's the formula for finding the circumference of a circle? 2 pi. Funny, if I go all the way around, I've got how many radians? 2 pi. So circumference equals 2 pi if the radius is 1. That's why 360 corresponds with 2 pi. Divide both by 2, that's why 1/8 corresponds with pi. It's because of the circumference. When you draw a number line, you put real numbers on the number line, right? You know, you got the 0, you got the 1, you got the 2, you got the 3. You got those numbers, right? Is 60 degrees on that number line? It's a degree. No, it'd be on a degree line somewhere. But pi is on that number line because it's a real number. It's just after 3. If I take this piece of string or whatever and wrap it, it would go from here to here. I've actually worked with tape measures that have pi's on it for measuring tires. You know, tires have a different circumference when they have a certain amount of air in them, right? Do you know they actually shave tires so they have more surface area on there for racing? You air them up to a certain spec, you run the razor across, that way it's all flat. Why would they want it to be all flat? Why don't they want all the little bumps and stuff when they're racing? What? Less friction, more surface area, better traction and more control, higher speeds. The more you have to grab a hold of, the faster you can go around a corner. Okay? So they actually inflate them, run the razor across, make it all smooth, and deflate them. Well, you have to know how far you're going to do that. So around this tape measure were a bunch of pi's for circumference. Very interesting. Very expensive to do that. All right, so we got 1 radian, 1 degree equals, well, oh, I see. You take that, and that's your unit conversion. Okay? So 180 degrees equals pi, and pi equals 180 degrees. That's kind of like our Rosetta Stone or whatever. Interesting. Moving on. Oh, here's the unit circle written in a horizontal table. I know, isn't it great? You got the first quadrant. Who? No, I don't copy it down. I write it as a unit circle. You got one? Where's that? Everybody have their unit circle from before? Yes. That's the first thing you open on your note card. Yeah. The unit circle. It's got the degrees. It's got the radians. It's got the quadrants. And this is in quadrant 2. This is a... Oh, wait a minute. Here we go. Quadrant 4. And quadrant number 3. So everybody's got their unit circle from before, right? You take that and you put it on the note card. It should take up about half of one side. Okay? Now the girls can always do this. The guys have problems. I don't know why. You know why? Yeah, they probably, and they don't really care. They just start writing without any, regard to the size or the shape they have to work with. Yeah, it does. So anyway, so you should be able to do that, right? I mean, this isn't something new. Everybody knows that pi over 6 is a little bit up off the x-axis, central angle 30 degrees. Okay? All right, fantastic. I told you some of this is going to repeat. There we go, 30 degrees. But that's a different way of looking at the unit circle than you're used to. Okay? Nice. Moving on. Converting. We can do that on the fly. All right, so if the angle is given a standard position, find two positive coterminal angles and two. Let's not do two. Let's do one. I'd be happy with one. All right, give me an angle coterminal of 570. How'd you get 210? So I have 360 and got 210. Nice. That's the positive. What about the negative? 210. Whoop, right here. Sorry? 210. What about a negative angle? Yeah, negative 150. Oops. Negative 150. Those are both coterminal, right? I love the radians. 3. Is that a 30 degree, a 60 degree, or a 45 degree reference angle? The 3. It's a 60, right? 2 pi over 3 is in which quadrant? Second. 2 pi over 3. So give me another angle that'd be coterminal with this. I do this in calculus, and they look at me like, what are you doing? How much? That's in degrees. Let's stick with radians. Let's stick with the theme of the problem. What? How do you do one lap in degrees? 360, right? How do you do one lap in radians? 2 pi. Oh, fractions. You can do it. It's been done before. How do you write 2, the whole number 2, and a fraction of 3? 6 pi over 3, isn't it? That's 2 pi, isn't it? So it's going to be 8 pi over 3 is a positive. And what about the negative? Right, just change the positive to the negative, and what do you get? Negative 4 pi over 3. How'd you do that? Well, I don't know. If you take 2/10, subtract 360, you get negative 150. So far, so good? I subtracted it from 2 pi over 3. If you subtract it from 8 pi over 3, aren't you going to be back here at 2 pi over 3? Okay? Negative 5 pi over 4. Well, you're going to add one lap to it, right? You're going to add 8 pi over 4 to it, aren't you? And you end up with 3 pi over 4 as one answer. And now you're going to subtract 8 pi over 4, aren't you? Negative what? 13 pi over 4. Those are coterminal, okay? It helps with the fractions. The reason you want to take your unit card and put it on that half of a note card is because you're going to put about 40 identities on there with it. And if you try to put 40 identities with your unit circle on a piece of paper, that piece of paper is going to get left behind somewhere. Because I see some of you looking at your unit circle thinking, I'm good. Well, you're good for now. But later on, you're going to want everything on one reference that fits nicely into your calculator. Because you're always going to have your calculator when you do math. You might not always have that piece of paper when you do math. Okay? And then on the 10 for 10s, I let you use and any quizzes, I let you use a note card. One time I had a quiz, 20 points, everything was off the note card. See, people had the note card. You know what happened? I found half the people didn't even have a note card. What's up with that? That'd be, yeah, the first one's coming at you possibly Friday. Okay? Yeah, interesting. Oh my gosh, what's this? It's what? No, it's the ancient Babylonians. What's this? This is the seconds, right? This is the 0 column, the first, the seconds. How many minutes are in a degree? 60! Woohoo! Oh, how many seconds are in a minute? Woohoo! All right. Find the angle that's supplementary. What's supplementary mean? Equals what? 180. Fantastic. So if I write 180 as 179 degrees, sorry, I need this. 59 minutes and 60 seconds, I can subtract 152 degrees, 12 minutes, and 4 seconds to get my answer, correct? Supplementary means add up to 180, right? Oh, because this 60, what happens when you reach your maximum in your base? You go to the next column, right? So this is actually the same as 1 minute, which will carry this one, so 59 minutes plus 1 is 60, which is the same as 1 more degree. So this is a fancy way of writing 180 degrees. I like that. Don't you? What do you know? You gotta be kidding me. Oh, you can take the weenie way out if you want. Oh my gosh. Oh my gosh. All right, ready? Take 180. Hold on. Minus 152. Now, your calculator determines how you do this next part. I'm going to go to angle. I'm going to hit degree. 152 degrees. 12. Second, and don't outthink yourself. Just wait for me. 2, or that tick mark gives me 12 minutes. Okay? Don't. 4, and that is under the quotes. Is that above the minus sign? Where's the quotes at? Plus sign, all right. Alpha, plus sign. Some people put 2 tick marks in. That's only true if you have an 82. You put tick mark, tick mark, tick mark. And then I want my answer. Go back to angle. And number 4, I want my answer in degrees, minutes, and seconds. So you come up with 27 degrees, 47 minutes, 56 seconds. That is not nearly as much fun.
Oh, yes, it is.
No.
Having a blast.
No, it's not as much fun. Well, see, look, you got 56 seconds right here. 59 and 12, you got the 47 right here. Woohoo! And then you got the 27 right here. You can go old school.
Yeah, we don't know how to get the one
Hey, 60 turns into 1. You add 1 plus 59 turns into 60.
Huh?
That turns into 1, you just 1.
See, if you have never run a race, you don't know how a stopwatch works, I can see how this would be very confusing. You know, because you don't know on the 59th second it goes to another minute. You think it goes to like 63 seconds. 63 seconds is the same as a minute 3. Wait, I don't have one today. I didn't get any new ones for Christmas. I'll make one up for tomorrow. Oh, wait a minute. 15.9 degrees. That one is easy. You see how it's not in degrees, minutes, and seconds? So you take 180. 180 minus 15.9. And your answer is 164.1. Yeah, 164.1. So you just take it and subtract it from 180. That one you don't have the DMS because you don't have this. This is still very much used in longitude and latitude, the way of measuring angles like that. Okay, you gonna make it? Oh, I know, it's great. Any more down there? No, I think we're good. Find the exact, all right, what is 120? You. 2 pi over 3, very good. Negative 135. Who's up next? Is it 2 o'clock yet? Oh, it's 1 o'clock. I got an hour to wait. o'clock I go shopping. Negative 135. What? Negative 5 pi over 4. No, I'm getting new shoes. 210. What is it? 7 pi over 6. So you're getting those off the unit circle, right? Or you can convert them. Makes no difference to me. What do you say? Who? Okay. All right. I don't know. Just basically memorizing it, I guess. Pi over 6. What is that one? Wait a minute. How many degrees are there in pi? Without looking at your notebook. 180. What's 180 divided by 6? 30 times 5 is? Thank you. She was not going to answer. Jessica's not here. She can't answer. All right, you. World's not ending.
Yeah.
4 pi over 3.
So,
4 pi over 3, I'm waiting.
I don't know.
You can't say that. New Year's resolution. If I hear I don't know again, I'm going to give you a quiz. 240. What is it? What is it? Good. I want to hear you say it. If I want to hear I don't know, I'd call this kid. 11 pi over 4. What is it? I don't think so. 495. You see that little symbol right there? That's Babylonian for degrees. Okay? Yeah. All right. Express in terms. Oh, I give this question on the test. 65% of the students miss it. Huh? 65% of the students miss it. And then they say, that question was cheap. Want to tell them how to do it. Do you see the degree symbol in this? So this is in radians. 1.5 radians. Some people would think that meant 1.5 degrees and write it as 1 degree 30 seconds. Or 30 minutes, sorry. No, that's in radians. You have to change it to degrees first. How do you change it to degrees? How many degrees are in 1.5 radians? Oh, come on. If you got pi in 180, where's 1.5 going to go? So you'll take 180 times 1.5 divided by pi, right? Is that right? All right, 180. 180 times 1.5 divided by pi. So far, so good? Now, how do I change 85.94366 into degrees, minutes, and seconds? Yeah, I go to angle. Second, angle. That's the easy way of doing it. Then you have 85 degrees, 56 minutes, and 37 seconds. Okay? Some people like that, some people don't. 85 degrees, 56 minutes, 37 seconds. Now, don't fall into that trap of 1 degrees and 30 minutes. It doesn't have a degree symbol, so you know it's in radians. Make the conversion, you'll be fine. Okay? All right. I say we're about done with this section. We'll spend 1 day on it. How do you express this as a decimal? Well, yeah, you can do it the old school way, 83 plus 17 over 60, or you can do it the other way. Clear. 83 second angle. Degrees, what was it, 17 minutes? Second angle minutes. Press enter. 82.283 degrees. Okay? 83.283 degrees. Who? Moving on, that's what that means. What's this in degrees, minutes, and seconds? Hopefully you'll never forget what these buttons are after today. And no, I will not help you during a quiz or test of where the buttons are. A1.7238 second angle DMS. There we go. So it's 81 degrees, 43 minutes, 26 seconds. That's in decimals, that's base 10. Degrees, minutes, and seconds means base 60. Okay? They're actually called cuneiforms. They have little wedges. Have you ever played Trivial Pursuit?
Yeah.
That's kind of like what a cuneiform is. In fact, they say that's where it came from, was a Babylonian drawing of a cuneiform in a circle. The widgets, that's where the idea came from, to use that as game tokens. Interesting. So, no, I didn't get that as a tweet. I got that as an undergrad.
Oh, we're out of time. Look.
Oh, I'm not. Got the 5-minute warning. He can't be peer pressured into doing the 5-minute warning. He has to. Oh, it is? Okay. All right. If the arc is given. Oh, arc length. S equals R times theta. Oh, there's a catch. Theta has to be in radians. It's nothing more than finding the fractional circumference of a circle. I mean, really. You found the circumference by taking, 2 pi r, multiplying it by the fraction. That's what this is, only a different way. You guys remember that, right? You had theta over 360 times 2 pi r for the old arc length. Well, if you take this, 20 is how many radians?
20?
Yeah, it's pi over 9 times the radius, which is 3. That's how you use this equation. If you did it your way, the old way that Mr. Duvall showed you, you'd put the 20 and the 360 right here. You get, 1 over 18 times 2 pi times 3. And the 2 and the 18 cross off, give you a 9. It's the same equation, just written a different way. Okay? If you can remember this or you can remember that. That's all the way to 30. That's about the end of this section, isn't it?
Darn, that must be pretty hard.
Yeah, area's the same way. Hexagon. Nice! Old school. A tornado's core? Are you kidding me? I saw that. Gulliver's Travels, the inverted whirlpool. Did anybody see that?
No.
You're missing out. Anyway, maybe we'll answer a homework question on that tomorrow. That's kind of cool. But anyway, we're just going to, I don't know, go through 45. Every other odd. Okay? I don't know. Page what?
369.
369, 1 through 45, every other odd.
Yeah.
You know what every other odd means, correct? Yeah.